So hello, everyone. My name is Chris Münch. I am in a new office of Enapter in the Enapter Development Center here in Seattle. That's in the very far northwest corner of the United States. So if you go all the way over to California and then straight up to Canada, the last exit before Canada, that's Seattle. And that's where our office here is hosted. And my team and I were working with the core team of Enapter to work on integration software and some new features that are coming in the web portal and the gateway. And this is what I'm talking today about. So I have a couple slides prepared for you guys, and I hope you're, follow along. First, I will talk a little bit about the Enapter solution architecture. Then we go a bit about the cloud and the app. I will show the Electrolyzer WebGUI real quick, which is new in the latest firmware. And then we talk about the main point. We are actually here. We're working on an OPC UA connection in the software for the gateway and the electrolyzers, and hopefully also the cloud. So, and I will show a little demo of that at the end. So how does the cloud look? Actually, the whole solution integration looks like from the Enapter point of view. There is a central point, the intelligent gateway, which is a very easy to manage NUC, basically, that can talk to all the local devices, so-called UCMs. And you see there's an RS-282, RS-485, an Ethernet-based one, and a CAN bus one. And with that, you can talk to all sorts of third-party devices that you want to connect into your ecosystem of your Enapter system. The way of looking at the devices in your gateway is either through a cloud interface or through a mobile application that you can download on Apple's Apple Store or Google's Google Play Store. I do have some screenshots of all that, so I can show you these things live. But before I do that, I want to go into the couple of the layers that the ecosystem, the software ecosystem of the Enapter EMS, which is the energy management system, provides. You see the teal layer on the bottom. This is what Enapter provides, all the firmwares, the gateways, rules engine, the cloud, dashboards, and analytics. These are all core components that come from Enapter. And then you have an integration layer where you can basically add new blueprints. You can connect to other devices. You can look at the web IDE. You have command line tools to manipulate devices. You have community repositories where third parties can add their blueprints and their integrations to, and then of course, lots of documentation. The handbook is one of those. You also see two links here, the marketplace.enapter.com. This is where you find the blueprints. And it's a constantly growing amount of integrations that you can find there. Our lab here in Seattle is also working on a couple of integrations that will show up shortly. The installation layer is then for the installers. They can basically go to the marketplace, download new blueprints, and see how they can integrate that with other systems that they encounter at the customer sites. They have templates for typical installations, which make it very easy to create new installations. And helping with that are commissioning and maintenance wizards that guide you through those templates very easily. And then, of course, logs to look at what's going on in the system. And then for the end user, you have mobile apps, you have the WebGUI directly at the electrolyzer. You can fire alerts that go into your email system or on your phone as an alert. And you get recommendations what you can do in order to optimize your system. This complete ecosystem is provided by Enapter and can be extended in many directions. This is a screenshot of the Enapter Cloud. I will switch to that in the demo and show you a live view of exactly my home. I have a gateway running where I added some devices that are not necessarily supported by Enapter out of the box. So I wrote my own blueprints for that, which I then give back to the community in the marketplace, enapter.com. We here at the EDC, I call our lab EDC, Enapter Development Center, we are helping with new blueprints and also give advice back to Enapter's core team how to optimize and improve the user experience of the cloud and the mobile app. In fact, let me switch to the cloud right now that you can see how this thing looks like. But this is a live view of my house here. You see where I'm located in Duval, Washington. If you zoom out, you see Seattle here. I'm a little bit far on the east side, but that's where my house is located. I have a solar system on my roof. I have batteries from LG running, the LG Razor Prime batteries, and they're actually connected with our new OPC UA client to the Enapter system, and I will show that in a demo later. And I also have power meters running. These are span panels. If you haven't heard about span, that's a smart panel replacing the breaker panels in your house. And I can measure for each and every breaker in my house how much power is going through that, which is very interesting in combination with the batteries in case of a power outage, I can optimize my house consumptions of all my breakers according to my battery status. So this is a live view of the cloud, and I will come to that a little bit later in the deeper demo. The phone app looks like this. So you have also your overview screen, how many devices you're running. You see each and every device. This is an Android screen. You see all the devices in what state they are. I can, for example, look at the same span panel and see my AC power usage of my span panel. And I can even drill into the charts even further to see exactly my power consumption over time. Air conditioning is going on a lot today, so you see those spikes when the air conditioner went on and back off. And I can look at that for the last hours, for the last 10 minutes. I basically just turned off the air conditioning, so we have a little ditch here. So this is kind of the mobile app. The mobile app also allows you to send commands to different devices. So you have here, for example, a relay that it can be used to switch lights or even other devices on and off. And that can be done from the mobile app very easily. In the same way, you can do that in the cloud by going to your devices and trigger those switches. Let me go back to the slides. I want to not jump too much ahead. This is the Electrolyzer WebGUI. So this is a new feature in firmware 1.6.0 and anything that came above. It basically allows you to directly connect to your electrolyzer via Ethernet and then look at your most important data of the electrolyzer right in a WebGUI. You don't need to install any app. You can directly access that with your browser. And of course, since it's a local web server, you can have all sorts of different topologies in your network that it's supported. You can have multiple devices connecting to one electrolyzer, or you have one device connecting to multiple electrolyzers. It's all very easy to manage with the WebGUI. The OPC UA projects are what our office is mainly working on. I am a long-term member of the OPC Foundation. I'm actually a founding member of the OPC Foundation. Back in '96, I joined the OPC group at the time. At that time, I was working for Siemens in the SCADA area. I was one of the architects of Siemens WinCC. And in that capacity, I wrote the first OPC servers and clients for Siemens at the time. And since then, I'm still involved in the working groups of OPC. Started OPC UA to work on OPC UA when I was at Microsoft. So I switched from Siemens to Microsoft. Inside Microsoft, I was the subject matter expert for industrial automation, and again joined the OPC Foundation from the Microsoft side. These days, the focus of OPC UA is on modeling, and we're trying to model the energy devices of the future in forms of complete data models that can easily allow plug and play between devices using OPC UA. OPC UA's latest incarnation can also run on top of MQTT. So there was a question earlier, would MQTT also been available? And you see that already here as an optional connection that the gateway supports. The OPC UA client is already in the gateway firmware 2.02. And I will show a little blueprint how this looks like. It's a very simple interface that allows you to access OPC UA servers. And we here work on the OPC UA server, which is the invert for external energy management systems that want to get data out of the Enapter system and then use for centralized management that might have existed before the Enapter system was installed. There's a big need for connecting multiple energy management systems in a bigger system. You can also think about community-based hydrogen systems that have their own energy management system that want to access the home energy system of the people that live in the community and want to share this information. And with OPC UA, you can very finely structure how you want to have the access permission done in an IT secure way. We also work on the servers for certain categories of devices, batteries, power meters, energy sources, and again, other energy management systems in form of these node set models that allows you to really easily connect these things together if they follow those models. If you're not familiar with OPC UA, it stands for Open Platform Communication, and the UA stands for Unified Architecture. There was a former version of that. If you're longer, I'm almost 40 years now in this business, and the very first version of OPC was actually a Microsoft standard called OLE for process control, which has been repurposed because OPC was very successful and they want to keep the name, so they changed what the acronyms actually mean. And in the meantime, it also became an IEC standard, 62541. You can look at this link and learn more about OPC UA. But if you want just a 1-minute overview what OPC UA is, let me start this video and I hope you can hear the audio.
What is OPC? OPC UA is an open standard that specifies information exchange for industrial communication, particularly on devices within machines, between machines, and from machines to systems in a convergence of IT and OT. It can be used with any software platform, Windows, Linux, Mac, Android, well, you get the picture. And this makes OPC UA scalable, from minimal embedded controllers to massive cloud infrastructures, even mobile devices. OPC UA is equally suited in a closed network or utilized via the internet. Don't worry though, security is baked into the protocol for access control, authentication, and encryption. Because of its flexibility, OPC UA has been widely adopted in industries like automotive, food and beverage, oil and gas, energy and utilities, packaging, building automation, and so on. So, as manufacturing moves to the industrial Internet of Things Industry 4.0 realm, OPC UA is already poised to fulfill requirements.
So I hope that gave you a nice quick overview. This is the link to the YouTube video if you want to watch it again in peace. The OPC Foundation has their own YouTube channel, and a lot of very good information is on this channel. So let's jump into the demo. We have a couple of minutes left, and I already showed the main site, the dashboards, all the devices that I'm having here in my system. This is my batteries that are running in my environment. These are my power meters. Unfortunately, I don't have any electrolyzers yet. Our office was established in April, so we're brand new on the horizon of Enapter. And I hope we get some electrolyzers here to populate this as well. The devices that I'm using are virtual devices. They basically connect to a battery outside the Enapter hardware. And I'm doing this with blueprints. And there will be a talk about blueprints coming up next, so I will not go too deep into it. But I wanted to show you real quick how a blueprint for OPC UA looks like. Very, very simple. You create an OPC UA client. You define the tags in the server that you want to read. And then basically you're reading the tags, converting the values to numbers if necessary, and send the telemetry to the Enapter system. So very, very simple to use OPC UA. Another very cool thing of the Enapter Cloud are rules. At this point in time, you can use rules to push data from your internal system out to other systems. So as long as there's no OPC UA or MQTT available, you can use those rules, for example, to read data from devices and then post them in a regular interval to other systems. So for example, I'm reading the telemetry data from this device out here. I think that's my RS-485. And then I'm executing a command. And this command is, again, a blueprint in another virtual UCM. And this happens on a loop. So basically, every once in a while, when the loop and the rule kicks in, this data is sent to a third-party system that wants to have this information from the Enapter system. So I think this is a very short demo for the OPC UA client. And if I look at the time, we're at the point where we need to go to questions because I only have 3 minutes left. So I would invite Stefan to moderate the question.
Coming in here. So thanks, Chris. It seems you made it crystal clear because there are no real questions, but you created some kind of interest. So there's a person asking if we can grant access to a demo site. So they want to, play with a software, test it out, check it out. So can you say something on that if a demo is available?
Yeah, so there is a demo version in the Enapter app. So I showed you the app earlier here. If you download and install this app and you don't have an Enapter system yet, you can actually run a demo site in the app and test out certain things that the demo site allows. So it doesn't require any registration. You basically just click on the demo, and then you have like a virtual environment that you could play with. Also, the software of the gateway is free to download. There's a download link. We should make that available to the folks where they can download the gateway software. It's all free. If you have a strong enough PC available, and the site where you can download the software explains what the minimum requirements for this PC are. And then you can basically install your whole system yourself. You don't need to buy anything. It's all free software. The easiest demo version is really the app on Android or iOS. And if you want to get into a more cloud-based demo, then you will have to install a gateway. But again, it's free, so it's just more work than the app.
Okay, cool. One question adding to that is if the demo version can create blueprints as well for testing purpose.
Actually, that's exactly what I did. So I'm using the demo version on my gateway. So the app on the phone does not allow this. So you're in a closed system. But the demo version that comes with the gateway, you can write your own blueprints. You can try out things. That's exactly how we work at this point in time with our cloud.
Okay, cool. And perhaps just to give an outlook, so in the next session that I will present, I'm going to create some virtual UCMs, install blueprints. So there's more information to come on that topic.
Exactly.
Okay, Chris, then thanks a lot for your presentation and for being available.